Balancing redox reactions is a little more involved than balancing regular reactions. So in this video, I am going to give you the steps to balance a redox reaction using something called the half reaction method. There are other methods that you can use to balance redox reactions. This one is really reproducible and really straightforward, so I definitely recommend it. I'm going to give you those steps, and then we're going to go through an example together. So there are 5 steps. One of them has some sub-steps, but the first step is to assign oxidation numbers to determine what is oxidized and what is reduced. And we talked about assigning oxidation numbers in an earlier topic. The second step is to separate the one reaction that you were looking at into an oxidation half reaction. So this will be a reaction that only shows oxidation and a reduction half reaction. And then we will balance the half reactions separately before we put them back together. So balance each half reaction, and you should do this in a specific order. So first you balance all elements except oxygen and hydrogen. Then you will balance the number of electrons gained or lost. You'll balance the net charges. And you'll need some extra information in order to do this. You'll need to know if the redox reaction is happening in an acidic solution or in a basic solution. In a lot of places, this will be explicitly marked for you, but there may be some cases where you need to take a look at the components of the reaction and determine that for yourself. So the net charges will use H plus when it's an acidic solution, and we'll use OH minus when it is a basic solution. After all of this, you can finally balance the oxygen and hydrogen, and we'll do that by adding water. Once all of that is done for each half reaction, then you will make the number of electrons gained in the reduction half reaction equal the number of electrons lost. And you'll see how we do this when we do the example. And then you'll add the half reactions together. And the goal in step 4, when those electrons are equal to each other, in one half reaction, they'll be on the reactant side. In the other half reaction, they'll be on the product side. So when we get to step 5 and add everything together, you won't see the electrons that were transferred in the reaction. All right, so let's do an example. And I'm going to label each of these steps with the number that corresponds to the list that I just gave you. So our reaction is MnO4 minus aqueous plus Br minus aqueous turning into MnO2 solid plus BrO3 minus aqueous, and this is in an acidic solution. So step 1 is to assign oxidation numbers. So I'm going to do this for every component. You can, as you get faster at this, do some things like, for this example, if you look at all of the oxygens and what they are paired with, oxygen is not changing its oxidation number in any part of this reaction, but I'm still going to go ahead and label it as we go through this first time anyway. So manganese in MnO4 minus is +7. Each oxygen is a -2. This bromine is a -1. In MnO2, manganese is now a +4. Oxygen is still a -2. Br and BrO3 minus is a +5. And oxygen is a -2. Okay, so this is a redox reaction, so that's good since we're going to use these steps to balance it, because we have oxidation numbers changing. So in order to identify the pieces, remember we ask what changed, and the two things that changed were manganese and bromine. My manganese went from a +7 to a +4. So in order for the oxidation number to change that way, it had to gain electrons. So the manganese was reduced. And my bromine went from a -1 to a +5, which means it lost electrons. So the bromine was oxidized. All right, so I have identified my two pieces. The next step is to separate it into an oxidation half reaction and a reduction half reaction. So manganese was reduced, so it will be the reduction half reaction. And you can balance these in any order. So reduction was my MnO4 minus turning into MnO2. I've got both of my manganese pieces in here. And then the other part was the oxidation half reaction, which is the Br minus turning into BrO3 minus. And between these two reactions, I've accounted for everything that was in my original reaction. So you can't leave anything behind. It should be pretty clear what goes with what, and we'll talk about what to do with the extra pieces in some of the practice problems that are assigned. All right, so step 3 is to balance each half reaction. So again, I said it doesn't matter which one you start with. We'll just start with the oxidation half reaction. And we'll do this in the order that everything was listed. So here's my half reaction to start. Balance all elements except for oxygen and hydrogen. Well, that would just be the bromine, and I've got one bromine on each side. So that is done. I don't have to do anything there. The next step is to balance electrons gained or lost. So this was oxidation. It lost electrons. To go from a -1 to a +5, I have to lose 6 electrons. And those go on the product side for oxidation. Balance the net charges. So for net charges, on the left, I've got one thing with a -1 charge. So the net charges on the left is -1. The net charges on the right, I've got one thing with a negative plus 6 electrons that are each negative. So I have a net charge of -7 on the right. So you don't have to get them to 0, you just have to get them to be equal. And I'm in an acidic solution, so my only possibility is adding H plus in order to get the charges equalized. So I have to add those H pluses to the right-hand side, and if I add 6 of them, then my net charges go just a different blue color here. Now I've got 1 minus, 6 minus, and 6 plus. This is now a -1, and this side is still a -1. So that is what it means to balance the charges. And then balance oxygen and hydrogen with H2O. So on the right-hand side now, I've got 3 oxygens and 6 hydrogens, and on the left-hand side, I don't have any, but the amount of hydrogens and oxygens on the right-hand side, this is a perfect amount that I can balance it with 3 water molecules. So if you get to this point and you don't have the right number of H pluses and oxygens, or if this were a basic solution, the OH minuses, in order to make a full molecule of water, you should go back and check what you've done so far. Okay, so there's a lot of stuff written on this. I'm going to rewrite this. My balanced oxidation half reaction is 3H2O liquid plus Br minus, turning into BrO3 minus, plus 6 electrons, plus 6 H plus. I'm going to put some brackets around this. So this is the entire oxidation half reaction. So I finished up 3, but only for this half reaction. So 3 continued. I have to do it for the reduction half reaction. So MnO4 minus turning into MnO2. So from a +7 to a +4, I need to gain 3 electrons. So I need to add those electrons to the left-hand side of the reaction. NO2. All right. Well, I guess I skipped the all elements except for oxygen and hydrogen. I have 1 manganese on each side. Go ahead and underline that. And the oxygens I have to wait and do at the end. Then I do the electrons, then net charges. So on the left, I've got -4 for my net charges. And on the right, that's just a neutral molecule. So I've got 0. So I need to add my H pluses to the left, and I need to add 4 of them. So I'm going to go ahead and rewrite this since we keep adding things to the left-hand side. Plus 3 electrons, plus 4 H plus, turning into MnO2. And then balance oxygen and hydrogen with H2O. So let's see what I got here. On the right, I've already got 2 oxygens. On the left, I've got 4 oxygens and 4 waters. Well, 4 oxygens and 4 water and 4 H pluses, doesn't perfectly make water molecules, but 2 of my oxygens already show up on the right-hand side. So if I add 2 H2O liquid, I now have 4 H's, 2 oxygens here, 2 oxygens there, for a total of 4, and then 4 H's and 4 oxygens on the left. So this is my final result. I'm going to rewrite it all in the same color. MnO4 minus, plus 3 electrons, plus 4 H plus, turning into MnO2 plus 2H2O liquid. Put some brackets around this. Okay, so step 4 is make electrons gained equal electrons lost. So for step 4, where we're going to make electrons gained equal electrons lost, what I have done is copied down the 2 balanced half reactions that we just did. So I've got my oxidation half reaction and my reduction half reaction, and I'm going to underline the electrons in each of these. The way that we balanced it, the oxidation half reaction has 6 electrons in it, and the reduction half reaction has 3. So what we are going to do is use the fact that you can treat these reactions kind of like algebraic expressions, and just do a little bit of technically algebra to get the number of electrons so they will cancel out when we add them together, right? Because these electrons are on the product side and these electrons are on the reactant side. So in most cases, it will be relatively straightforward to pick a multiplication number to get these to be equal. If you go too high, you'll still have to reduce the reaction down, so we'll try not to do that. But if my top reaction has 6, my bottom has 3, if I just take this bottom reaction and multiply it by 2, then I'll end up with 6 electrons, and when I add these together, they'll totally cancel out. So that is, we have to technically do the multiplication to finish step 4, and then add them together for step 5. So I'm going to do these, I'll label this step 4 and 5. So just rewriting my reaction that isn't changing. Plus 6 electrons plus 6 H plus aqueous, and then my bottom reaction, after I multiply that through, I'll have 2 MnO4 minus plus 6 electrons plus 8 H plus, 2 MnO2 and 4 H2O. So my 6 electrons on each side will cancel, but then I have some other reductions to do. So you could do this before you add them together. Figure out which way you make the least number of mistakes. If it's easier for you to add them together first and then reduce everything, you should do that. But here I've got 3 waters on the left and 4 waters on the right. So all of these will go away. This is going to cancel down to just 1 water on the right. And then I've got 8 H pluses on the left and 6 on the right. So it's going to reduce to 2. So in the end, I've got 2 MnO4 minus plus Br minus plus 2H plus turning into BrO3 minus plus 2 MnO2 plus 1 H2O liquid. And this is finally our balanced redox reaction.